Sometimes you're asked to sketch a graph given certain features, and here's an example. So let's look at this. First of all, we're going to draw in our axes. Now, what's it telling us? It's telling us that f-3 equals 0, so that's telling us that the gradient when x equals 3 is 0. So what that means, we know the gradient is 0 at a stationary point, so somewhere along that line where x equals 3, we've got a stationary point, either a maximum, minimum, or point of inflection. It also tells us that f-5 is 0. Okay, so the gradient when x equals 5 is also 0. So we've got another stationary point, max, min, or point of inflection. Now this point here tells us this f'4 is 0. So if the second derivative is 0, that means we've got a point of inflection. So at x equals 4, we know we've got a point of inflection. So I'm just going to change the colour here, so we know that's a point of inflection. What else do we know? We know at f of 0 is 6. So that means when x is 0, y is 6. So that tells us when x is 0, y is 6. So the y-intercept is 6. So the graph goes through that point. What else do we know? f'2 is greater than 0. So what that's telling us is when x is 2, because it's greater than 0 is the equivalent of a minimum, so it means it's concave up. So we know it's concave up when x equals 2. So it's going to be in that sort of form. So the likelihood there is it means we've got a minimum here because it's concave up. And we know the change in concavity is at the point of inflection. So the likelihood is, if that's a minimum, then that's going to be a maximum. And at this point, it changes from concave up to concave down. So what else do we know? We know that already know that it goes through 6. So that fits with it being concave up. But we know at -1, it's not differentiable. So that could be for two reasons. It could be an asymptote, or it could be a sudden change of gradient. What else does it tell us here, though? It tells us that f-x is 1 for x less than -1. So what that's telling us is the gradient of the graph is 1 for any values of x less than -1. So because the gradient is 1 for a range of x's, that means we've got a straight line. Straight line with gradient 1, so that's going to look like that. And that sudden change of gradient explains why it's not differentiable at x equals -1. And the last thing they tell us is f-x is less than 0, so that means the gradient is negative, so the function is decreasing for x is greater than 5. And yes, we already knew that. That just confirms that that's a maximum or local maximum. And then after x equals 5, the graph's just going to carry on down. So it's decreasing because the gradient is negative. Now, the specific y values don't matter apart from the y-intercept because you were given that y value. You were given that y is 6, so it has to go through that. But the y values for the turning points aren't important as long as you've got the turning points at the right, or stationary points at the right position in terms of x.